Okay, now we are going to discuss one more concept that is very important, electrolysis. So what is the electrolysis? So the name itself indicating that lysis means separation and by using the electricity. Is it clear? The decomposition of chemical substance, it is in aqueous state or in molten or fused state into its constituent particles under the influence of electricity. Is it clear? The decomposition of chemical substance in its aqueous or molten or fused state into its constituent particles under the influence of electricity, that is called electrolysis. Electro means electricity, lysis means separation. Is it clear? Or dissociation. So electrolyte is dissociated under the influence of the electricity, that is called electrolysis. That we call that electrolysis. And next another one, in that few terms we will discuss electrolytic cell. Electrolytic cell. So this is the device. This is a device which convert electrical energy into chemical energy. So the device which converts electrical energy into chemical energy, that is called electrolytic cell. So electrolytic cell is a device, it converts electrical energy into chemical energy. Next another one, in that cell we use the electrodes. What we call that? What are the instruments we use here in the electrodes? So what are the electrodes? Simply we can say the entrance and exit of the electrons. What is that? The entrance and exit of electrons. Entrance and exit of electrons is called electrodes. There are two types of electrodes we have. How many types? Two types of electrodes. One is anode. This is positive. Why? Because this is connected to a positive terminal of battery. Terminal of battery. It is connected to the positive terminal. That is a anode. And another one, cathode. So cathode is negative. Is it clear? So it is connected to the negative terminal of battery. Anode is a positive one. It is a connected to the positive terminal of battery. Cathode is negative. It is connected to the negative terminal. So flow of electrons. This is the anode. This is the cathode. This is the flow of electrons. Flow of electrons from anode to cathode. And flow of current. Flow of current from cathode to anode. So the directions are always reverse. So electrons move from anode to cathode, but current flows from cathode to anode. Is it clear? Now, at anode, oxidation takes place. At anode, oxidation takes place. Like oxidation in the sense losing the electron. At cathode, reduction takes place, means gaining of electrons. Reduction takes place, gaining of electrons. Is it clear? There are two types of electrodes are there. There are two types of electrodes. What are they? One is active electrodes. Another one, inert electrodes. What is the difference between the active and inert What are those? Active electrodes which are participate in the electrode reactions. Active electrodes which are participate in the electrode reactions. So that is involved in the electrodic reactions. Example, zinc, copper. Is it clear? The electrodes which participate in electrode reactions, they are known as active electrodes. Inert electrodes, the electrodes which do not involve in the electrodic reactions. Example, graphite, gold, platinum, etc. So active electrodes, inert electrodes or inactive electrodes. The electrodes which are involved in the electrodic reactions, they are active electrodes. Example, copper, zinc. The electrodes which does not involve in the electrodic reactions, you will see that what are the electrodic reactions, what is the difference between that using the active electrodes or inert electrodes, you will see that, but you remember this one. Active electrodes which do not involve in the electrodic reactions, do not involve in the electrodic reactions. Inert or inactive electrodes, they do not react in the or participate in the electrodic reactions. Example, graphite, iron, platinum. Next, another one, discharge potential. What is that? Discharge potential. What is a discharge potential? So this is a minimum potential required. This is a minimum potential required to discharge ions. This is a minimum potential required to discharge ions at corresponding electrodes. Is it clear? This is a minimum potential required to discharge the ions at particular or with respect to electrodes. They are called discharge potential. Discharge potential, it is a minimum potential required to discharge the ions at corresponding electrodes. It is a minimum energy required to the ions which discharge at the corresponding electrodes. That is a electrode potential. Next, another one, preferential discharge. What is that? Preferential discharge. So what is a preferential discharge? So discharge potential means there is a minimum energy required to discharge the ions at corresponding electrodes. Next, another one, preferential discharge. So what is a preferential discharge? So the preferential discharge means in the given electrolytic cell, if we found more than one ions, one ions means more than one cations or more than one anions. Generally, you know, anions moves towards anode, cations moves towards cathode. Yes or no? So if in the given electrolytic cell, if you found more than one anions or more than one cations, so they move towards the respective electrodes depending upon the discharge potential. Depending upon the discharge potential, which ion has the lowest discharge potential. Which ion has the lowest discharge potential, that will discharge at the corresponding electrode first. Listen once again. So discharge potential which is having the ion which is having the low discharge potential, that can discharge at the corresponding electrode first. Which is having the higher discharge potential, that will next. Is it clear? So discharge potential, the minimum energy required to discharge ions at corresponding electrodes. Preferential discharge, if more than one cation or anion is present, that particular cation or anion can discharge, which is having the low discharge potential at corresponding electrodes. So this is a few important terms, and we will see the order also now. Once again I repeat, electrolysis. The dissociation of chemical substance into its particles into species under the influence of electricity. Electrolytic cell, the device which converts electrical energy into chemical energy. Electrodes, the entrance and exit of the electrons is called electrode. There are anode which is connected to the positive terminal of the battery, anode which is the negative, it is connected to the negative terminal of the battery. Next, flow of electrons, anode to cathode, flow of current, cathode to anode. At anode, oxidation takes place, at cathode, reduction takes place. Anions moves towards anode, cations moves towards cathode. So, what are the active and inert electrodes? The electrodes which can undergo electrodic reactions or participate in the electrode reactions, they are active electrodes. Which do not participate in the electrode reactions, they are inert or inactive electrodes. Example for the active, zinc and copper. Example for that inert electrode, graphite, platinum, iron. So discharge potential, the minimum energy required to discharge the ions at corresponding electrodes, that is discharge potential. Preferential discharge, so the preferential discharge in that if more than one cation or anion present, if more than one cation or anion present in that cell, that which is having the lower discharge potential, that can discharge first. That can discharge first. Okay, now we see the order of discharge potential of anions. What is that? Order of discharge potential of anions. So F minus greater than phosphate, PO3 minus greater than SO4 minus greater than NO3 minus greater than hydroxide ion greater than chloride ion greater than Br minus ion greater than I minus greater than CO3 minus 2. Is it clear? So this is the order of discharge potential. So which is having the higher discharge potential? F minus is more. Which is the lowest? CO3 minus 2. So now come to the order of discharge of anions. So which ion will discharge first? Which is having the lower discharge potential, that can discharge first. So CO3 minus 2 first. See carbonate ion, iodide, bromide, chloride ion, hydroxide ion, nitrate ion, sulfate ion, phosphate ion, F minus, fluoride ion. So order of the discharge potential, which is having the highest order discharge potential order, F minus. So order of discharge of anions, which one will discharge first? Which is having the lower discharge potential. Is it clear? Next, order of discharge potential of cations. So which is having the highest discharge potential? Lithium plus more than, potassium ion, sodium ion, calcium ion, aluminium, manganese ion, zinc, Zn plus 2, Cr plus 3, Fe plus 2, ferrous, H plus, cupric, Q plus, this is a cupric, Hg plus 2, Ag plus, platinum plus 2, and R plus 3, which is the highest discharge potential of anions, lithium plus, which is the lowest, R. Now, order of discharge potential of anions. So, Au plus 3 greater than, Pd plus 2, platinum greater than, silver plus greater than, Hg plus 2 greater than, Cu plus 2 greater than, H plus greater than, Fe plus 2 greater than, Cr plus 3 greater than, Zn plus 2 greater than, Mn plus 2 greater than, An plus 3 greater than, Ca plus 2 greater than, Na plus greater than, K plus greater than, Li plus. Reverse of the discharge potential. Order of the discharge potential, we will get the order of discharge of anions. So which is having the highest discharge potential, that can discharge next. Which is having the lower discharge potential, that can discharge first. These are the two things we have to remember, and this order also we have to remember. This is very important. Now we will see that identify the products obtained during the electrolysis of following substances in the presence of electrodes. mentioned in the brackets. So first we are taking the inert electrodes. So first aqueous sodium chloride. So sodium chloride aqueous means NaCl we are having Na plus Cl minus, and we are having bottom H2O means H plus OH minus. Is it clear? So if you observe the discharge potential, so there are two cations are there, two anions are there. Yes or no? Na plus and H plus. What is that? Na plus and H plus, which is have the lower discharge potential. Na plus and H plus. Na plus is having the lower discharge potential. Yes or no? Na plus is having the lower discharge potential. Sorry, Na plus and H plus. So here H plus is having the lower discharge potential. So at cathode cations. So cations that can reduction takes place. So 2H plus 2 electrons come from gives to the hydrogen gas at cathode. At anode. So in anode we are having the two ions Cl minus and OH minus, which is having the lowest. Cl minus is having the lowest discharge potential. So anode oxidation takes place. Cl2 plus 2 electron. So in the aqueous NaCl, Na plus and H plus, Cl minus, OH minus. So preferential discharge, which is having the lowest discharge potential. Na plus H plus. H plus is having the lowest discharge potential. So that can discharge first. Liberates hydrogen gas in the cathode, and Cl minus, OH minus. Cl minus is having the lowest discharge potential than OH minus. So that can easily, Cl minus can easily convert into chlorine gas by losing the 2 electrons. Now come to the aqueous copper sulfate, inert electrodes only. So copper sulfate Cu plus 2 electrons. Yes or no? Next H2, aqueous means H2. H plus OH minus. H plus OH minus. Now come to the point. So there is a competition between the Cu plus 2 and H plus. Which is having the lowest discharge potential? Cu plus 2. So at cathode what will happen? Reduction takes place. At cathode reduction takes place. So here copper plus 2 plus 2 electrons turns to Cu. Next there is a Cu plus 2 plus SO4 minus 2. So and there is a competition between the sulfate ions and hydroxide ions. When compared with the sulfate ions, hydroxide ions are having the lowest discharge potential. Yes or no? When compared with the sulfate ions, hydroxide ions have the lowest discharge potential. So 4OH minus gives us O2 plus H2O plus 4 electron. Here you can take 2, here you can take 4, here you can take 2. Total 4 oxygens and 4 hydrogens and 4 electrons. So here we have to remember the which is having the lower discharge potential, which is having the higher discharge potential. Next 50% H2SO4. Is a 50% H2SO4. Generally H2SO4 undergoes dissociation H plus and HSO4 minus. H plus and HSO4 minus. There are cations H plus and OH minus. Is it clear? So at anode, is very important. At anode, this HSO4 minus turns to H2S2O8 plus 2 electrons. What is that? H2S2O8. This is called peroxydisulfuric acid. What is that? Peroxydisulfuric acid. This is an anode. At cathode. Cathode what will happen? Reduction takes place. So 2H plus 2 electrons gives us hydrogen gas. Is it clear? So this is a few important sums to explain the discharge potential, which one is the highest and which one is the lowest. Is it clear? This is in the presence of inert electrodes. In the presence of inert electrodes. Okay, now we'll see the aqueous silver nitrate. Anode is a silver, that is active, and cathode is a platinum, that is a inert. If you see that AgNO3, that dissociates Ag plus NO3 minus. Is it clear? So if you see that an anode Ag plus electron and cathode Ag plus electron Ag. This is a solid. If in the case of active electrode, that is our anode, we may not expect any product at anode. Is it clear? Once again I am saying that when anode is active electrode, mostly no product is obtained at anode. Mostly no product is obtained at anode. Next, suppose aqueous CaCl2. So CuCl2, Cu plus 2 plus 2Cl minus at anode. Cu active anode. Cu plus 2 plus 2 electrons at cathode. Cu plus 2 plus 2 electrons. The copper can deposit at the cathode. So finally what we can say that no product formed at the anode. Anode is an active electrode. Is it clear? So when anode is an active electrode, we may not expect any product at the anode. Is it clear? So this is in the presence of active and inactive electrodes, discharge potentials.